So for this assignment, we are tasked for finding like the application of second order circuits in any medical devices. What I've chosen is the RSC circuits in MRI RF coils, radio frequency coils. Let's move on into the topic. So the basics of MRI. MRI has few components, and one of them is the radio frequency coils. The radio frequency coils is one of the main components, which also generates a magnetic field perpendicular to the gradient coils in order to excite tissues and also detect signals from them for image construction. And the image is also depends on the image quality is also depends on the radio frequency calls, and which can be analyzed with signal to noise ratio, the Q factor, the sensitivity, and the coverage. The design is the it can be designed. The circuits can be designed as a resonant structures, and it can be schematized as an equivalent RLC circuit. Um, Before we proceed to that, we to the circuits, well, we need to know what is Larmor frequency. The Larmor frequency is the precession rate of magnetic moment around an external magnetic field. So it is the frequency at which also in MRI, uh, it can be the frequency at which hydrogen nuclei resonate and emit signals. For, for so for different um, um, magnetic field strength, they will also have like a different number of frequency as it depends on the equation. For hydrogen, is around 64 megahertz for 1.5 teslas, and 128 megahertz for 3.0 teslas MRI. Moving on to the next part is the RF circuit role in radio frequency coil. The It consists of resistance, inductor, and capacitor, which is tuned to the Larmor frequency. RSC circuit has a oscillating frequency properties, which needs to match exactly with the um, Larmor frequency. So from the formula given, you can use this. We can use this formula in order to match the Larmor frequency. So V is the voltage source of the transmit call for the transmit call, or the simple sample induced voltage from the receive call. R is the mechanism and sample losses. L is the inductance, which is the energy stored in the magnetic field. C is the system capacitance, which tune the resonance and match the impedance of the circuit. I is the current flow maximized at Larmor frequency. Moving on to the application, the circuit's application in radio frequency calls. So for transmit, they have two parts: transmit and receive. Radio frequency calls excites protons at resonance. That it will cause a greater precession, as shown here in the diagram for the signal. It has an exponential value as it will be decaying over time. So that is the function of the receive coil, which detect emitted signals during nuclear relaxation, which produce also induced current. As we can see here is a free induction degree from the diagram. Is a signal obtained through receiver coils through MRI spectrometer. Occurs after sample excitation. Is a time domain signal which can be converted into by Fourier transform into a frequency domain, which also can further analyze the peaks, which also represent the resonance occur when the Larmor frequency is matched with the tune frequency. So moving on to the image quality of radio frequency calls in MRI. So the resonant RLC circuits will affect the image quality of radio frequency calls. So the higher the signal to noise ratio will have the higher the image quality. As you can see from the picture, there has a little noise when the SNR is higher, while there are more noises in with an SNR lower SNR. Is important to maximize the signal to noise ratio for image quality to improve clinical decision making. So the factors can affect as signal to noise ratio is tuning capacitance. If it's not exactly tuned to the Larmor frequency, it will have a lower frequency. The impedance value is also needed to be adjusted to the 50 ohms. Um, and also the circuit quality factor, such as the quality factor of the capacitance, must have a very high quality factor in order for them to have a low resistance, which also improve the image quality. And also higher magnetic field strength will also result in higher signal to noise ratio, but there's a limitation that can cause certain limitation when using higher magnetic field strength. You will also need to have a l- lower lower or higher frequency of the Larmor frequency. And then here is represented the relationship of the signal and also resist the resistance, the magnetic field strength, and also thermal noise. And conclusion. So radio frequency calls in MRI acts as a resonant circuit RLC circuits, which is a second order circuit, in order to match the Larmor frequency. For tuning and detuning, it's important for imaging process of various MRI image. Circuitry ensures functional components work efficiently to achieve best image quality. Also, it will help in a life-saving biomedical. It will also help in biomedical imaging in life-saving scenario. And these are the reference that I referred for my topic. Thank you thank you for listening.